Have you ever wished that making remote calls across your worker for worker-to-worker communication was as easy as calling a local function? Well, today's your lucky day because Cloudflare Workers now support remote procedure calls, or RPC for short, natively in Workers. This is a game changer because you don't have to wrestle with boilerplate HTTP, no need for setting up routers, no need to pass response, none of that. You can now directly call functions across workers as easily as if they were method calls in a library, and that's really cool. So in this video, we'll look at a few code examples of how RPC works in workers, and that should give you a good idea of when and how to use RPC in workers. My name is Confidence. Let's get started. So looking at my IDE, I have two workers that are connected using RPC. On the left here, I have worker 1, which we will refer to as the server. Worker 1 implements an add function that takes two numbers and adds them together. Very simple. Then worker 2, which is the one to my right, and here we have the client, which consumes worker 1. So you can take a look at the code we have here on line 7. It's making use of the add function and passing in 2 and 3 as the arguments to the function, and that should get added and our result gets returned whenever a fetch request is made to this worker. And this is how simple RPC is. So we've just used RPC to make a call to the add function on worker 1, passing the values and get a response and send it back to where it needs to go. And the only configuration you need to do to get this working is declare a binding. So right here in worker 2, if we take a look at the wrangler.toml, we have a binding to worker 1, which enables us to communicate to worker 1, and that's really all you need to do. So we can fire this up. What I'm going to do is run both of these workers, and then we'll see if this actually works. So let's create a new terminal and we can do a quick npm run dev. So we have worker 1 running on port 8787. We can also do the same for worker 2. So this is going to be npm run dev, and it's running on port 51924. We don't have to worry about the ports because the entry point of the application is worker 2. So now I can go into the my API playground, send a get request to worker 1. Let's fire this up. And here you see the response is 5, which is what you expect. But taking a look at the code for this, you see how simple this is. We did not have to worry about setting up all of the boilerplate HTTP stuff. That's setting up the routes, sending a request, receiving the request, passing the data, figuring out the business logic, then formatting the data, sending it back to the client, and the client has to do the exact same thing, like take that data out, pass it, and then use it for its purpose. Like, this is so simple. It feels like we're just calling a method, right? We're calling a method on a library named worker 1, and we're passing the values and receiving the response, which is really, really simple. And the beauty of this is that RPC in workers support all structured clonable types. So for types like dates, you don't have to stringify the dates, send it over, and have it passed back into a data object for you to use. You can just directly pass data across the wire. Functions, methods, objects with methods can also be passed across the wire, and it makes it really easy. I'm going to show you an example right here. So here in worker 1, instead of just passing in 3 and 2, let's pass in a function that actually performs the addition. So this function is going to take 2 parameters, and it's an array function that returns a multiplied by b. So we're changing the behavior of what the add function is supposed to do here. And if we head back to worker 1, now what we'll do here is we can receive that function, and instead of performing the addition, what we're going to do here is make a call to the function. And right here, we're just going to call the function, passing the parameters, which is awesome. You notice that TypeScript is yelling at me here because RPC has great TypeScript support, but we'll ignore those warnings for now, and let's see if this works. So I'm heading to the playground here, and I'll send a request to it, and you see that the response is 6 because 3 times 2 is 6. But what we've done here is, take a look at this. We've passed a function to our RPC call, that at the end of the day calls the function with the parameters we passed in the first place. Like we're doing a lot of magic, so to say, here. But if you love to see how RPC works, I'll be leaving a link to the docs in the description below. But another view of what is happening here is that when we make a call, an RPC method call to the add function here, we're actually calling a stub or a JavaScript proxy function that gets executed inside of worker 1, as you'd expect. And in this case, we're also passing in a function, which is the function parameter that get called here. But that function is not sent over the wire, but rather is executed here in worker 2, where it is defined. So it's a really interesting it's a really interesting technology, and I highly encourage you to take a look at the docs. But this means that you're not limited to data that can be passed across methods when you're using RPC. And the beauty of this is that it's really fast. So this is not only fast because I'm running it locally, but this runs really fast. Absolute zero network latency, because both workers, worker 1 and worker 2, runs on the same thread. So it makes it really fast, just like you're calling a method in a library. And of course, great TypeScript support, and that makes it like really lovely to work with. So I'm sure you're wondering, right? This is a really simple example. It's a trivial example. What does RPC look like when you build real applications? Let's take a look at that in the next example. Taking a look at this example we have here, which is the second example, we have two workers again. So we have an auth service, and the auth service has a user and then has an entry point that defines how to get a user. We'll come back to the auth service, but we have an app that consumes the auth service. And what the app does is that the app calls the check cookie method on the auth service worker and then pass in the cookies from the request headers to that service to get that cookie verified. So here we get two responses. As you can see, we get an authorized state. If authorized is false, we don't want to continue with the operation. But if it is not, it means we've gotten a user, and then we can perform operations on the user, like get the user's profile and then print it to the screen. That is by returning it as a response. Now heading back to the auth service, you can take a look at what a user is here. So a user is a class. It's a simple class that has two methods. We have the get profile method and also the set profile method, and this allows you to perform operations on a user. And here is where we define the check cookie method. It takes a cookie, does the check, and returns a payload that has the authorized status and also the user object. Now if you love to see both of these examples using RPC, I have this on my GitHub repository, so I can show that to you. All you want to do is go to github.com/megaconfidence, and don't forget to smash the follow button over here. But switching to the repositories tab, there's going to be the workers RPC example, and you can see both the example we saw earlier using worker 1 and worker 2 and the auth service worker pair. So I'll have this linked in the description as well. All right, heading back to the code, we should be starting the app worker. So this should be npm run dev, and then we go to start the auth service. This should then be npm run dev. Okay, so this is running, the app worker is running on port 8787, and now we can head back here and send this request, and we get a response saying hello John, which is the name of the user we have provided this cookie for. So that works, and that's great. But taking a look at this, something you notice is that this is a realistic use of RPC, in fact. And if you've built a lot of HTTP servers, this is something you have to do, which is passing a user cookie, trying to get it validated, and then giving the application or the client the ability to perform operations on that user. But that is quite different from what is going on here. If you take a look at the implementation of check cookie, what we're doing here is a little bit different. It's called capability-based security, and we're only giving access to a user only when the verification is successful. That's the only way to get access to a user. Although a user is defined earlier here, which in this class, but the only way to get access to a user is through the check cookie function, and only when the cookie is valid, that is when you get a user, which is really cool. But then at the same time, if we go back to the client, so let's go back to the client, you also notice here that we don't have to pass the cookie in every time we need to create an operation or perform an operation on the user. So for example, we only verify the user once, and then we get access to the user, and then we can go ahead to call methods on the user. So I can go ahead to call as many methods as I want to on the user, but I don't have to present a cookie each time, which makes my code very free from boilerplate, sending over cookies, getting to have those cookies validated before going on to perform the operation. And one other thing you notice here is that taking a look at the user class, okay, let's go back here. Taking a look at the user class, we don't have that cookie stored anywhere in the user as well. So it makes it really easy and really ergonomic to write complex applications, because we don't have to do a lot of boilerplate code to set up the business logic we need to write at the end. You can just go ahead, write what you need, and get this done. And one other interesting feature of RPC is the ability to perform promise pipelining. So remember, if we go back here to the app, that the operations we perform on the user doesn't run on the app worker, it runs in the auth service worker. And that means we're making a request to the auth service worker, and in some cases, especially when you're using a durable object, that may actually have to happen over the network. But what RPC in workers allows you to do is to batch a list of promises or a list of operations, send it over to the server, have all those operations executed, and have the results sent back. So for instance, what we can do here is I'm just going to perform an operation on the user. So let's call this set profile method. So this is user.setProfile. And what we want to do is, so let's set the user's name to John, which it's the user's name in the first place. We can set the age to 40, and we can set an email. So email should be john@gmail.com, and we don't have to await this because the last call to the user here already has the await. So we can batch multiple operations. I can have multiple set profiles, and I don't have to await any of them. And here, just to test that this works, I am going to, so let's delete all of this, and we can do a json.stringify profile. So we see the response. All right, so this is saved. Now we can head back to the API playground, send a request, and here you see that we get that user's data. Okay, now we get everything updated. We get the user's data with the name, age, and email, and we did not have to await any of the asynchronous calls to the auth service. We only had to await the last one, which means that all of these operations were batched, sent over to the auth service, executed over there, and then we have a response returned back at the end by putting a last await. If you'd love to learn more about promise pipelining, we'll talk more about it in a future video. And really, that's it. That's all you need to know about Workers RPC in a nutshell. So I'm curious, what's your current approach to connecting microservices when building on Workers? Do you think RPC could simplify your architecture? Share your thoughts in the comments and let me know. In the next video, we'll cover more advanced concepts when using RPC, such as pipelining, like I talked about earlier, error handling, and also memory management. So don't forget to get subscribed so you won't miss out the next video, and I'll catch you in the next one. Take care. Bye.